Hello everyone. We've been given three expressions here and we've been asked to prove that one is equal to another or they're equal to one another. So let me give names to these expressions. Let me call my first expression as number 1. 1 plus tan squared a by 1 plus cot squared a. We'll have to prove that this is equal to 1 minus tan a by 1 minus cot a the whole square. And let me call this number 2, and both of them are equal to 3, which is tan squared a. So let's proceed, and let's first take the first one. Let's take 1 plus tan squared a upon 1 plus cot squared a. And now tan a can be written as the ratio of sin a and cos a. So let me rewrite this: 1 plus sin squared a by cos squared a, and similarly we can write cot a as cos a by sin a. So we are substituting, instead of cot squared a, it can be written as cos squared a by sin squared a. Now look at the numerator of this term. 1 cannot be added to sin squared a by cos squared a because the denominators are not common. So let's make the denominators common by multiplying 1 by cos squared a by cos squared a. We are not changing the value 1 because we are multiplying both numerator and denominator. We are using the same term. And similarly here, sin squared a by sin squared a. So this now will be equal to cos squared a plus sin squared a upon cos squared a, and the denominator on addition would be equal to sin squared a plus cos squared a by sin squared a. At this point, let's recall the Pythagorean identity which we have proved here at Math Decoded. Sin squared a plus cos squared a is equal to 1. Let's use this here. So you can refer to that later in case you need some clarity, but let us use this here. So now the whole thing would be equal to 1 by cos squared a upon 1 by sin squared a, as we are rewriting sin squared a plus cos squared a as 1. And what is this equal to? This is 1 by cos squared a multiplied by the reciprocal of 1 by sin squared a, which is sin squared a by 1. And see what this is equal to. This is equal to our third expression, tan squared a. Sin squared a is equal to sin squared a by cos squared a is equal to tan squared a. So now ultimately we have proved that expression 1 is equal to expression 3. And let me also point out that if there is one another way of doing the same thing, starting from here, there is another way of doing the same thing by using the same Pythagorean identity. Just divide the Pythagorean identity both sides by cos squared a and see what happens to it. Sin squared a plus cos squared a becomes equal to, if you divide it by cos squared a, we will get 1 plus tan squared a is equal to secant squared a. Of course, we have mentioned this also at Math Decoded. You may refer to it. And similarly, if you divide both sides by sin squared a, what will happen if you divide both sides by sin squared a? This Pythagorean identity, if it's divided both left and right hand side by sin squared a, we get 1 plus cot squared a is equal to cosecant squared a. So now if you start off with this first expression here, 1 plus cot squared a can be immediately replaced with cosecant squared a. This can be written as cosecant, let me write it here, 1 plus tan squared a is equal to secant squared a. So this whole expression can be written as secant squared a by cosecant squared a. And from here we would directly jump to this step, the second step, isn't it? This is the last but one step of when you take it as tan a is equal to sin a by cos a. But here you can jump these two steps if you immediately recognize this and using the Pythagorean identity you rewrite 1 plus tan squared a as secant squared a. We can directly say that this is equal to 1 by cos and 1 by sine, and so ultimately the same thing, we'll be able to prove that the expression 1 is equal to the expression 3. I just deviated slightly to tell you that there is one more way of attempting the same problem. Now we have proved 1 is equal to 3. Now let's deal with the second one, 1 minus tan a by 1 minus cot a the whole squared, and let's see how we go about doing the second one. Let me take a fresh page now. Okay, yeah, so 1 minus tan a by 1 minus cot a the whole squared. So what is this equal to? Using the same technique, let me write tan a as 1 minus sin a by cos a, and cot a can be written as cos a by sin a, and don't forget to square both of them because it's what is given in the expression. So if you square it, you get, using the same technique as we did previously, by making the denominators common, you get cos a minus sin a upon cos a and the whole thing squared, and this is being divided by sin a minus cos a upon sin a, and this is also squared. Now how can we simplify this? It's just easy. Let us split the squares, cos a minus sin a the whole squared, or let me take a fresh line here. Yeah, it is cos a minus sin a the whole squared by cos squared a, and what happens to the denominator, I'll bring it here and multiply it using the reciprocal of the denominator. So sin squared a by sin a minus cos a the whole squared. Now what is the difference between these two terms, cos a minus sin a the whole squared and sin a minus cos a the whole squared? They are just the negative of one another. Suppose I take out minus 1 as common from this term, I get minus sin a plus cos a, which is the same as that, and this minus 1 also has to be squared because it was within a square. So what do we get? We just cancel these two. They are divided by one another. So ultimately what remains is sin squared a by cos squared a, which is once again equal to tan squared a, which was our expression 3 what we began with. So now we have proved that in the first page we had proved that 1 is equal to 3, and now here we have proved that 2 is equal to 3. We started off with the second expression and we have proved that that was equal to tan squared a. So by the transitive nature of equality, we can say that if 1 is equal to 3 and 2 is equal to 3, we can say that 1 is equal to 3. This is what I mean by the transitive nature of equality. If something is equal to another thing and the second thing is also equal to the same other thing, then we can conclude that 1 is equal to 2 and this is also equal to 3. So we have proved what we began with. We began with 1 plus tan squared a by 1 plus cot squared a. First we proved that this is equal to tan squared a, and in the second page we took this particular expression, the second expression, and we also proved that this is equal to tan squared a, and hence we have proved that all the three are equal to one another. I hope you followed this procedure. Thank you.